Hi everyone, this is your 2.1.4 lesson. It's titled What Makes Zero? Using Zero to Simplify Algebraic Expressions. So follow along as I read your introduction. Today you will continue your work with rewriting algebraic expressions. As you work with your team, ask yourself and your teammates these focus questions. How did you see it? How did you write it? And is this expression as simplified as possible? So we're going to look at question 235 to start. (235) says, how can you represent with zero with tiles on an expression mat? With your team, try to find at least 2 different ways to do this and more if you can. Be ready to share your ideas with the class. So we're going to just start this by using unit tiles. So we could have a couple things here. I could have a positive tile that I'm going to shade in the positive region, and I could have a negative tile in the negative region. That would be a zero pair because positive plus a negative would be 0. If I wanted to do it a separate way, I'm going to start with a positive tile again. And down here, a negative times a negative makes a positive. So I would actually need this tile. It can't be a negative because if a negative times a negative, that would be a positive. So 1 plus 1 is 2. Would actually have to be a positive as well. Negative times a positive is a negative. So in summary, to create a zero pair, opposite tiles in the same region or the same tiles in opposite regions create your zero pairs. Oh, that word's supposed to be same. Sorry, couldn't see that. We're gonna move on to our next problem, which is 236. So if you look down, it's right below. 236 says, Gretchen used 7 algebra tiles to build the expression shown at right. Build this collection of tiles on your own expression mat or use the 236 student e-tool and write its value. Represent this write this value. That's all of part 1 or part A. So I'm going to have you pause the video right here and I'm going to have you write the value. If you were back with me, you have written the value for this expression, so let's look. Well, we have 2 positive x tiles, so 2x, a negative x tile in the positive region, so minus x, plus a unit tile in the positive region. In the negative region then, which when we go down to the negative region, I like to put a subtraction symbol. That means you're going down. We have 3 positive tiles. Notice how I put that in the parentheses. That's because it's in the negative region. So that negative would need to be distributed to that positive 3. So 2x minus x plus 1 minus 3 because it's in the negative region. And those are 3 positive tiles. You could have also had 2x minus x plus 1 minus 3. Some of you might have simplified. You might have had x plus 1 minus 3. Some of you might have had x minus 2. Okay. Part B says, represent the same value 3 different ways, each time using a different number of tiles. Be ready to share your representations with the class. So let's talk about this a little bit. We want to represent that same tile collection in multiple ways. Okay. So let's talk about our positive tiles first. We can leave everything that's up there. So I'm just going to redraw them. And then these 3 tiles down here at the bottom are truly negative. So if I wanted to move them up to the positive region, they would be, oops, that should be shaded in, I'm sorry. They should be negative tiles. So we still have 2x minus x plus 1 minus 3. Now go ahead and pause the video, and I would like you to try this 2 more times. Okay, if you're back with me, that means you have attempted that 2 more times, and we will talk about that in class. So please look at problem 237 now. This is good. This is extra practice for you. So if you want any extra practice, make sure you try problem 237. 238 is what we're moving on to next. It says, write the algebraic expression shown on the expression map below. Build the model and then simplify the expression by removing as many tiles as you can without changing the value of the expression. Finally, write the simplified algebraic expression. So we're gonna do the first one together, and then you're gonna try the second one. So we can make some 0 pairs. Remember, from our other page, we said that opposite tiles in the same region or same tiles in opposite regions make 0. So let's look for our opposite tiles in our same region. There's a pair right there, and that's it. Now, same tiles, opposite regions. Okay, we have 1 pair right there and 1 pair right there. So those are all 0 pairs. So the only thing that we have left, well, we could write out what we had. Let's write out what we had first. We had x, 1 positive x, minus 2x, minus 2, and I'm going in my negative region, minus just 2. So now I need to distribute that negative, so it's x minus 2x minus 2 minus 2. So now we've figured out all of our 0 pairs. Oh, I'm sorry, plus 2. Okay, let's go back through this again because I made it a little more confusing than I should have. So when we were rewriting this, we had 1 positive x tile, 2 negative x tiles in the positive region, 2 negative unit tiles in the positive region, and then we went down to our negative region. So that's why that negative is there on the outside of the parentheses. And inside the negative region, we had 2 negative tiles. That's why this should have been a negative 2. That was my mistake. Negative 2. So now when we would distribute, we would have x minus 2x minus 2 plus 2. So our 0 pairs, which we have already done on our mat, only leaves us with a negative x. Go ahead and pause the video, try part B, and then we will talk about it. If you're back with me, part B should be completed. So we're going to go ahead and take a look at part B. When you wrote it out, you should have had x minus 2 plus 1 in your negative region, so negative, our subtraction sign, negative 3 plus x. So now notice that everything in the negative region is inside that parentheses, so when I distribute, everything will be getting that negative. So x minus 2 plus 1 plus 3 minus x. Now let's look at our 0 pairs. Remember, opposite tiles, same region. Same tiles, opposite region. So now, what do we have left? Well, we have in the negative region, we have 2 negative tiles and a positive x tile. So when we distribute that negative, we would have 2 minus x, which is left in our, which is what we have left on our mat. Okay, we're going to try 239. (239) says, simplify each of the following expressions by building it on your expression mat and removing zeros. Your teacher will give you instructions about how to represent your work on paper. So you're going to be drawing these tiles. So let's draw them together. So we have 3x. I like putting them in, that's just in the positive region. Remember, shading is positive. And then notice we have negative and then parentheses, so now we're in the negative region of our mat. We have another positive x. We actually have 2 of those. And we also have 4 positive unit tiles down here. Okay, we're going to build the second one as well right now. So we're going to start with 7 unit tiles in the positive region. Okay, now we have our negative in parentheses, which means we're going down to the negative region. Please notice this is for y. We're dealing with y's. So again, they will be shaded. We also have 3 negative unit tiles down here because that is what is in the parentheses. Now going back up top, because we're back in the positive region, because that plus sign tells us that, we have 2 positive y tiles and 4 negative tiles. Your job is going to be to complete 239 A and B, and when you come back to class, we will talk about it. If you have any questions, make sure you email.